In this video, we're going to consider how to produce algorithms using pseudocode and flow diagrams. So the specification states that in the exam, you need to be able to create, interpret, correct, and refine algorithms using pseudocode, flowcharts, the OCR exam reference language, or high-level programming code. A flow diagram, often referred to as a flow chart, is just one way of representing a sequence of steps in an algorithm. Here we can see that we start at the top. We input a number from the keyboard. We input a second number from the keyboard. We ask, is number 1 greater than number 2? And if it is, then we follow one branch. And if it's not, we follow another. Then there's different outputs depending on the outcome of that decision before the program comes to a stop. We can represent that algorithm using what's called pseudocode. Pseudocode is like a halfway between English language and actual programming code in a programming language. It looks a little bit like a programming language, but doesn't follow any specific syntax for one given language. Instead, it's more generic code that could easily be applied into any programming language that a programmer wants to use. So in this example, we're inputting our two numbers, and we're saying if number 1 is greater than number 2, then print the largest number is number 1, otherwise print the largest number is number 2, and then end. So it's exactly the same algorithm that we saw in the flowchart, it's just represented in a different way. As well as creating an algorithm from scratch in the exam, you might be presented with one already in the form of a flowchart or pseudocode, etc., and then be asked to refine it somehow. So here we see our previous flowchart from an algorithm to output the largest of two numbers entered by the user, and we're being asked to refine it so it will now output the largest of three numbers entered by the user. You would first need to identify the areas of the existing algorithm which need modifying. Well, we would clearly need to modify this top section to take in an extra input from the user, which you can see we've done here. And we would also need to modify this bottom section. Now this will require a little more thought, so why don't you pause the video and see if you can sketch out with a pen and paper how you would alter the bottom part of this flow diagram. And here you can see our refinement. So we've still got the is number 1 greater than number 2, but then if the answer is yes or no, we're performing another check, and depending on the result of that, we're either outputting number 1, 2 or 3 is the largest. Of course, in the exam, you may be presented with this algorithm in a different form, and you could be asked to present your answer in pseudocode, or your preference of either the OCR exam reference language or a high-level program code of your choice. Here's another example of a flow diagram. Now this algorithm calculates how much carbon to dose into a fish tank to keep nitrates at bay. It starts by asking what the nitrate level is, and says if the nitrate is above 10, then output 3 mil. If not, is nitrates above 2.5, and if they are, output 2 mils. And if they're not, is the nitrates above 1, and if it is, dose 1 mil. And if it's not, dose half a mil before coming to a stop. We can, of course, express this algorithm in pseudocode. Here's a comment just to explain the purpose of the program. Next, we've got a variable called nitrate, which is entered from the keyboard. We ask if nitrate is greater than 10, then dose 3 ml. Otherwise, if nitrate is greater than 2.5, then dose 2 ml. Otherwise, if nitrates is greater than 1, dose 1 ml. Otherwise, dose half a ml. It's exactly the same program, just expressed in a different way. So all flow diagrams use a common set of symbols. There are many symbols, but 6 of the most popular ones that you'll be expected to know for the exams are shown here. You've got a terminal symbol, and that shape represents the start or end of a process. Then you have a process symbol, and this shape represents something being initialized, processed, or calculated. You have a decision symbol, and this shape represents the decision. It will have a yes or no, true or false outcomes, which will be represented by 2 separate lines or paths exiting the shape. Then you've got an input-output shape, and this represents the input and output of data to the algorithm. And you have a shape representing a call to a subroutine. A subroutine will have its own flowchart, but when you call it from the main program, you need to express that call using this symbol. Finally, you have a line, and the purpose of the line with an arrow represents the control passing between connected shape. It's the flow of the algorithm. With pseudocode, there's no established convention of exactly what terms you should use, but in your exam, the examiners will use a particular type of officially defined syntax, so there is some commonality. This formally defined language by the exam board is known as the OCR exam reference language. As you will see all code in your exams presented in this way, it will be handy if you would become familiar with it. You'll notice that it's not a particular programming language. However, it does look a little bit like Python. This is deliberate, as OCR are well aware that most schools are using Python to teach programming at GCSE. However, don't panic if you're learning another language. OCR have stated that if an exam question asks you to write syntactically correct code in the answer to a question, then you may write your answer in either the OCR exam reference language or a high-level programming language of your choice. So comments are denoted with a double slash. Inputs use the input command, and variables can either be numbers or strings, which are identified in double quotes. The global command identifies that a variable can be used in any subroutine or function instead of it being declared inside the subroutine or function, which would make it only available to that particular subroutine or function. The keyword const defines a constant. These are values that don't change throughout the life of the program. Python doesn't actually support constants. You'd have to initialize a variable and then never change its value while the program is running to get the same kind of functionality. Casting is about turning one data type into another. So str is used to convert a number to a string. Int is used to convert a string to a whole number. And float is used to convert a string into a number of decimal places. The reason that you have to cast variables is because in memory they were stored with different bit patterns. You output to the screen using the print command, and iterations can be for loops, while loops, and do loops. Notice the syntax for each of these loops. In Python, the control of the loop is determined by indentation, but in pseudocode, and indeed in the OCR exam reference language, it's quite common to identify where the end of the loop is. Now, Python doesn't actually support do until loops, but you still need to be aware of them for the purpose of your exams. The difference between a while loop and a do loop is that a while loop will not necessarily have its code executed, but the condition is checked at the beginning of the statement. Whereas with a do loop, the code inside the loop will execute at least once because the condition is checked at the end of the statement. There are logical operators that you can use in condition statements, and these are and, or not. There are comparison operators. Note that the double equals is equal to, and not equal to is an exclamation mark and an equal sign. Different languages use different symbols to represent not equals to. You've got a less than or equals to, a greater than, and a greater than or equals to, and you must be careful not to confuse these different symbols. There are arithmetic operators. Addition and subtraction, signified with plus and minus, that you'll be familiar with already. Multiplication, signified with an asterisk or star symbol. A slash is a division. Mod is modulus. This tells you if there's a remainder when you divide one number by another. So example 6 divided by 2 is 3. There's no remainder. So the modulus of 6 mod 2 would be 0. However, 7 mod 2, or 7 divided by 2, would be 3.5, and therefore the output would be 1. There's one remainder. Div is integer division, so when you divide one number by another, 7 div 2, the answer you would get would be 3. It disregards any decimal places that are the result of the division. And then finally, you've got explanation, or to the power of. Selection is performed with if, then, else, else if, and end if. And again, in Python, the condition is controlled by indentation, but it's not uncommon in pseudocode and other languages to have an end if statement. An alternative to multiple else ifs is to use a case select or switch command, where you say switch X and then have various case statements which can match. With this selection statement, you can have more than two outcomes, and a default is the equivalent of an else. You terminate the switch command with an end switch. Now again, Python doesn't support the switch command. Instead, you have to use a series of else ifs. And then you have the string handling commands. .length returns the length of a string. .substring extracts characters from a string. .upper converts the string to uppercase and lower to lowercase. ASC returns the number of a character, and CHR returns the character from its ASCII number. Then you've got subroutines, which are split into procedures, which are defined using the keyword procedure, or functions, which are defined using the keyword function. Both may take a number of parameters or variables that they can use, and with functions only, if you wanted them to return a value, you'd use the keyword return. You terminate subroutines with either end procedure or end function as appropriate. Arrays and exams will be declared using the array command, and again notice in Python we don't have arrays, we have lists, but to all intents and purposes we can think of them as really the same thing. You also need to be aware of 2D arrays, so it's possible to define a grid structure using 2 dimensions. You need to be aware of how to generate random numbers. These are generated using the keyword random followed by 2 parameters, which are the range of numbers. E.g. random bracket 1, 100 bracket would generate a single random number from 1 to 100 inclusive. Finally, you look at file handling. So you can use open to open a file for read or write, and close to close a file once you're done using it. We use the end of file function to say whether we've reached the end of a file, and we use .readline or .writeline to read a line or write a line to the file we currently have open. And these are all the commands that you'd be expected to know in the exam. Now this video has assumed that you've got plenty of programming experience already, and therefore you recognise a number of these commands. If not, don't panic. As you get more practice with programming, a lot of these commands will make sense, but it's helpful to know how examiners will use syntax in an exam.